Question 5b. Magnesium and silicon have different types of giant structures. Describe the bonding in magnesium and in silicon. Include the names of the particles and describe the forces between the particles in the structures. I'm hoping what you're seeing now as you're going the further through this booklet you're going is the repetition you get in these structure and bonding questions. Okay, obviously these are from a variety of different OCR exam papers from different years, and they have different contexts looking at different elements and different compounds, but the basic underlying chemistry for all of them is the same. And I want you to make sure you realise that and understand that as quickly as you possibly can, is that the same explanations can be employed regardless of the context. Okay, and it's the same basic structure of questions what we had a few before in this collection. We're comparing structures. We're asked to talk about the types of force between certain particles. Exactly the same structure. So let's look at the different chemicals we've got. Magnesium, metallic, silicon, giants, covalent. We're told it's giants already, so it's helping us out in that sense. So giant metallic, giant covalent. Describe the bonding of magnesium and silicon. Include the names of the particles and describe the forces between the particles include and in the structures. Let's start with magnesium. Okay, we know it's a giant metallic lattice. Just state the structure. Even though it says it's giant, make sure you write it in the answer. Okay, you wouldn't really lose a mark in this instance because you're told it's giant already, but it's just making it nice and clear. A giant metallic lattice, so we've got metallic bonding present. Okay, we're asked to include the names of the particles and describe the forces. So essentially, all you're looking to give here is a definition of a metallic bond. Okay, if it's a giant metallic lattice, where are the attractions? So it's a strong attraction between positive, shorthand for positive there, plus sign and VE, positive metal ions and delocalized electrons. Okay, there's the particles, the ions and the electrons. Okay, and then for silicon, we know it's a giant covalent lattice. So there'll be a mark for covalent. Okay, silicon consists only of silicon atoms, so we're going to have strong covalent bonds. There's the force or bond between silicon atoms, and there's the particles. So look out for those keywords, those trigger words in the questions. Okay, describe the forces, describe the bonding, and between the particles. All right, they've played around with lots of variations of this basics question. Sometimes they give it to you in a table, and you're asked to fill in the table with the types of particles. But it tends to be this bit that students either miss or get wrong. So remember, a giant covalent structure, if it's just an element, will have covalent bonds between atoms. A giant ionic structure will have the bonds between oppositely charged ions. Metallic structures have the attractions between the positive metal ions and the delocalized electrons. Simple covalent lattices will have the London forces or intermolecular forces between molecules. So make sure you get that terminology right for your different particles.